All right, I hope you guys can see my screen.
Yes.
Okay, great. So let us go ahead and start today's session. So we will begin with introduction to HL7, and then we will be seeing series of topics just to understand the basics of HL7 out there. So today's will be the first session, and we will have another demo session for tomorrow, which will be session 2, and then we'll continue having sessions uh, sequentially for the people who want to go ahead and enroll in the training and proceed forward. All right, so let's go ahead and begin with it. So my name is Dixon. I'll be your trainer, and I have worked as technical architect and lead in HL7 integration space. I worked on various standards like HL7, Fire, CCDs, and X12, and so on. So these are all healthcare standards. If you're already from healthcare background, you would have a fair idea about these. I have almost 12 plus years of experience, actually 15 plus now. And I've worked on many various integrations and integration engines, which includes Rhapsody, Mirth Connect, Integration Buddy, Connector, and Ansible. Um, in this training, we are going to cover specifically about Mirth Connect, and we will take a deeper look at what Mirth Connect is from base. And we will also see some advanced topics like how to integrate with the database and construct HL7 messages and so on. So I've been training people online from the past 7, 8 years now, and it's been a very good journey. So that's a little about myself, and let's proceed with what are we going to look at today. So today we will talk specifically about introduction to HL7, and as I said, we will see where do we hear this term, where do we get to know about HL7, and we'll take a look at hospital workflow. So a few of you might be aware of the workflow at the hospital, and in general, we all may be aware of that, but that's where everything begins. So we'll take a look at hospital workflow, and then we will understand what is HL7, and then we will take a look at why do we need HL7, and then we will see how the name HL7 has been decided. We'll also see what is an interface. We'll also talk about what is the role of HL7 in an interface. And then we'll talk about interoperability and HL7 message structure, the basic structure of HL7 message, and try to understand how can we read an HL7 message in general, right? So a few general terms that we need to understand before jumping into the actual training, because we will be using these acronyms a lot down the line, not just in this session, but also through the entire training. So PM or PMS is practice management software or practice management system. So this application is used by the front-end staff or the receptionist to go ahead and register patients, schedule appointments, manage the billing, and so on. Next, you have EHR, which is electronic health record. This is the clinical software that is used by doctors, nurses, and all the clinical staff to register the patient clinical data. And then you have HIS. HIS is also a software. Again, it is called as HIS, HMIS, HIMS, and with many more names. Apparently, this is a software application which has all the modules that are present in PM and EHR. Okay, it has registration modules, appointment modules, and entire modules that are responsible for the clinical data. Then you have LIS, which is Lab Information System. This application is specifically used by the laboratories. So if they have to manage their orders and send out the results back, they use this software. Then you have ICD and CPT. These are two libraries that we will be using to represent the patient diseases. Every disease in the world has a unique ID, and that unique ID um, will be present in the ICD library. And then you have CPT, which is current procedural terminology. So this is basically the procedure codes that we have to uh, address the problems or address the diseases that patient has been facing. Then you have CCD, which is continuity of care document. This is kind of a document which will have entire patient history. And then you have HIE, which is Health Information Exchange, which is a central repository to exchange the data between different hospitals. Then finally, you have IHE, which is Integrating Health Enterprise. This is also a standard again to exchange data for HIE and CCDs. All right. So last three topics are not very much related to HL7 right now. I will be briefing you about what are the other healthcare standards that we have apart from HL7 version 2 that we are seeing through the training, so that you get a fair idea about, okay, we also have these other standards which we may have to learn or to upgrade ourselves more into the other standards of healthcare, which is fire and CCD. Right, so let's begin with hospital workflow. So this is a generic workflow that we will come across, an outpatient workflow. We are not talking about patient getting admitted to the hospital, but what happens when a patient walks in and comes in and uh, shows his problem and then leaves. So a patient will go ahead and first he will reach out to the receptionist. Sorry. So patient will come and talk to the receptionist. Receptionist would ask whether patient is here for the first time or has he been here in the earlier days. Uh, Based on that, they will make a decision whether to create a patient or update a patient record, right? So they will create the patient record or update the patient record, and these data will be saved in the PM application system. Next, what you have is they will also ask about what is the or which specific appointment they want, which specific doctor they want to meet. So they will take the appointment for that doctor. A receptionist will go ahead and schedule the appointment. And then an appointment will be sent over to the EHR system from the PM system. So this is the PM system that we have. And from this software, the data will be sent over to the EHR system, which is doctor's desk. Okay. And in the EHR, doctor will be viewing what all appointments he has, and then he will take an action accordingly. Now, after receiving the demographic and appointment detail into the doctor's application, which is EHR application, then patient will come and he will meet the doctor, and there patient and doctor will have a discussion with each other on what the problem is. So this scenario is called as an encounter. So encounter is an episode where patient and doctor are talking to each other to discuss their problem and then come up with a final solution for their problem. Okay, now doctor will try to diagnose the patient based on symptoms. If doctor is able to figure that out just by looking at the symptoms, great. But in most of the cases, as we do know, there will be certain tests that will be performed. So doctor will place maybe a blood test or a urine test and so on. And this order of lab test will be sent out from the EHR application to the LIS application, which is the lab information system, right? And lab information system will receive this order. They will perform the analysis of the samples, and then they will respond back to the doctor's application with the help of a result, right? And then once this is done, doctor will go ahead and suggest a treatment or prescribe a medication or injection or whatever it is. Once that is done, all the charges related or associated with these, it may be doctor's appointment charge, doctor procedure related charge, or lab related charges, everything will be sent back um, to the receptionist desk, right? And once the receptionist receives all the charges associated from EHR and lab, then they will go ahead and consolidate everything and then raise a claim and send it to the insurance company. Okay, so here we got introduced to three different applications, right? One is practice management, where the patient data is getting registered. And then you have electronic medical records, where the patient's medical records are being reviewed. And then you have lab integration systems, where lab is analyzing the patient samples. Now, the data is being exchanged between these three different applications. That's what I mentioned. But how do they exchange this data? Let's say there should be an integration between practice management and EHR system, right? So practice management should send the data to EHR, and EHR should send the data to lab information system. LIS should send the data back to EHR, or it may have to send the invoice or charge related data back to PM system. In order for these three applications to exchange this data, what they usually do is they will go ahead and integrate. There will be data integration engineers who will extract data from PM, let's say patient registration data from PM, and send it to the HR system. This process takes a lot of time, right? Because they will have to decide what format they have to exchange the data in, and what specific structure they have to follow while exchanging the data between these two systems. So if one application has to integrate with another application, it will really take a lot of time, because the engineer has to analyze the database of PM system. He will have to analyze the data base structure of EHR system, exchange data, which is a very tedious process and a time consuming process, right? So that was a major challenge. So this is like, let's understand with the help of a metaphor. Let's say we have three different people from three different countries talking to each other, and a person from US, India, and China, let's say, right? So if the Indian guy has to talk to Chinese guy, he has to learn Chinese and then talk to him. Or if the Chinese guy has to talk to a US guy, he has to learn English and talk to them. So this learning of another language and then conversing with the other person is a very tedious and time-consuming process, right? So that's where a common language has emerged, English as a common language, so that anyone in the world can talk to each other with that common medium of communication, right? So similarly, when the applications are exchanging the data between themselves, if they define their own data format, they define their own data structure, it will take a lot of time. Engineers on both the side has to sit with each other, discuss what format is agreeable to both of them, and then come up with a structure which both of them can follow and then implement it. So what HL7 has done is HL7 has made that easy. So like the way we have English language for common medium of communication around the world, the HL7 V2 or HL7 organization has come up with a common structure and the format which has to be used in order to exchange the data between all the healthcare applications. So as now the data structure and the format is common, which the engineers doesn't need to bother about. All that they have to do is they should follow this HL7 V2 data format. So they just have to extract the data, convert it into HL7 V2. Now that the other person who is on the EMR system side understands this language of HL7 V2, he will be able to interpret the data and then import the data into their system. Now, these two people don't need to discuss as they have to discuss in the other scenario where they have to create a format, create the structure, define what data should go where and all. So everything is predefined with the help of HL7 V2. For now, I am calling it as a language, but it is not actual language. It is a data standard which we will use to exchange the data between any healthcare entity. Any healthcare application. It may be PM, EHR, LIS, or it can be an HIS system, or it can be a radiology information system where images can be exchanged and so on. So there are many different entities within healthcare, and all of them are preferred to use HL7 as their data standard for exchanging data between different applications. Now, what is an interface? When we talk about an interface, interface is nothing but a bridge between two different applications. And it doesn't matter what database the design is in. So practice management system will have its own application and its own database, right? Similarly, electronic medical records have their own database. So these two applications will interact with each other with the help of HL7 V2. That's what we have seen in the previous slide. Now, once the data is being exchanged, it gets exchanged at the application layer. We'll talk about that in a little detail in the next upcoming slide. But basically, what's happening is the data is being exchanged between the applications, but not between the databases. So there will be an integration application in between, which will extract data from DB and then convert the HL7 message and send it. There will be an application on the other side which will interpret the HL7 V2 and then insert the data into database. So it doesn't matter what kind of database you have. You may have SQL database here, you may have Mongo database here. It doesn't matter. Apparently, at the end of the day, data is being exchanged in the form of HL7 V2, and that is being done through an interface, which is nothing but a pipeline or a bridge between two different applications to exchange the data. Okay. So, so what is HL7? HL7 is basically an health level standard. So this is established back in 1987, and the uh, term HL7 comes from a concept of OSI layers, where we are using top seventh layer of the OSI layers. We'll see that in the next slide. But HL7 is being used in more than 28 countries today, and we have various countries like India, Australia, China, US predominantly, and other countries are slowly moving or using HL7 as their data standard for healthcare data exchange. So next, why the name HL7? So why did we arrive, or how did we arrive at the name HL7? So if you see OSI model, OSI is Open Systems Interconnect. This model is primarily responsible for exchanging data, or we seeing the data being exchanged between two different entities. Now, let's say, for example, I am presenting my screen and you are able to see it on your screen. How is that possible? So my presentation layer is nothing but my first screen is nothing but my application layer, which we are seeing right now. Behind, so you can assume this, behind this layer, there are six more layers. And the last layer is connected to my Ethernet port. So what happens is whatever I am presenting here in the application layer will get converted into physical packets, and these physical packets will transmit over the Ethernet internet cables and is reaching you to your Ethernet port in your physical layer. And then it will be interpreted and you are seeing it in your application layer. Okay, so this is a very interesting model. You can go ahead and, if you are not aware of this, just try to understand or read more about OSI models. Our primary goal is not just understanding OSI models, because this is more from technical or data exchange perspective. For us, what is matter is the HL7 translations that we make, extract the data from database, construct the HL7, everything happens in the application layer, which is the seventh layer of OSI model. So that's the reason the number 7 has come, which is level 7. And as we are dealing with healthcare data, we have this term called health, hence it is called as health level 7. Okay, that's how we arrived at this name called HL7. So let's understand more about HL7. Why is the name HL7 is what we have seen in our previous slide, and what is the use of HL7? So HL7 has its own grammar and syntax, meaning HL7 will exchange the data in its own format, and HL7 v3.1, which is the one of the most famous versions, has around 12 chapters and 5 appendices. So there are more than 50 data types, more than 80 message types, and more than 86 event types as part of HL7 data standard. You may not be familiar with these terms right now. We will see this down the line, what is message type and what is event types. Data types are nothing but same like any other programming language. We have data types in HL7 as well. So let's look at the history of HL7. So it started back in 1987. An official standard of 2.3 was released in 1997. Then we had 2.3.1 released in 1999. A significant release of 2.5 was made in 2003. And when this was released, people upgraded mostly from 2.3 to 2.5 because it has a lot of changes which were incorporated at that point of time. And after that, in 2005, a new release of version 3 has come. So if you look at version 3 was not very much welcomed by the industry. There were a couple of reasons behind it. One, change in the entire structure of the message. With 2.x, you have a certain structure which is called as a pipe delimited file. Whereas if you move to 3, it's an XML definition file. So there is a complete shift from the data structure that we were using with 2. That is one thing. And getting an experts who are very well versed with version 3 was really difficult, because that was a new standard that was released at that point of time. Not only that, the second thing why people did not welcome it very much is because of the fact that it's not adding much value or not doing much more than what V2 does. right? Let's say you are upgrading your one of your application on your mobile. Why would you upgrade it? Because you want to use the new features and add some value to it. Similarly, when people want to move from V2 to V3, there was no significant value addition. And um, second thing is uh, this change in the structure has made it very difficult and cost consuming in order for people to move from V2 to V3. So that is the reason it was not very much welcomed by the implementers, and people did stick to version 2 itself. And after that, for that reason, version 2.8 was also released by upgrading the aspects or incorporating the incorporating the standards that were required from 2003 to 2013. Okay, so all around the world, people are still using HL7 V2 version 2 itself. Even new countries who are moving their data to a digital form are implementing their interfaces using V2. So V3 is not seen anywhere. But as part of V3, there was another substandard that was released, which is called as CDA, which is Clinical Document Architecture. So this clinical document architecture is a standard which will define how can you exchange documents between different healthcare entities. That is a massive hit because CCDs are used a lot in healthcare industry. Let's say patient goes to hospital one, his data is present in hospital two. Hospital one can request for data from hospital two, and they will send out a document back to them pertaining to certain encounter or certain visit of a patient, right? So that way, they will be able to view the entire data history of the patient. So CCDs was very big success, and there are many implementations around the world who are using CCDs today, which is part of version 3. Next, we have FHIR, which started in 2010. FHIR is the latest standard that was released by HL7 organization. So all of these standards that I'm talking about, version 2, version 3, CDA, FHIR, all of these are maintained and released by HL7. HL7 is the international organization. So FHIR is the latest standard released by them, and FHIR as a standard has a complete shift in the data structure, meaning uh, the HL7 V2 was used as fire V2 was used as pipe delimited file, whereas um fire is completely based on a JSON structure. Okay, and not only that, sorry, not only that, it was the communication models that we use to exchange fire are also in various ways. Now, many people ask me whether do we need to learn fire or we need to learn HL7 V2. Uh, So that's a good question, but the answer to that would be HL7 V2 has been there in the industry for the last 30 years. Now, Fire is very new compared to that. It began its development in 2010 to satisfy the needs that HL7 V2 was not satisfying, right? For example, the HL7 V2 message exchange is between the hospital entities, but let's say patient wants to view his data. Apart from the small patient portal, there is no effective mechanism to exchange the patient data outside the hospital. Okay, that's when Fire has come into play so that it can bridge that gap and make the data available to the outside entities, of course, following the security standards and all. But it would make it possible for other third-party applications to integrate with EHR through this standard. So the main purpose of starting Fire was to go ahead and make the data available to the outside world. Along with that, Fire also has the plans to replace HL7 V2, HL7 CDA standards as well. But Fire itself is evolving, and even today, we are not still at a point where we can say that all the resources or all the data sets in Fire are completely standard, meaning they don't change. So they tend to change. So Fire will take a lot more time to evolve and say that, okay, this is the final standard that we have. So until then, V2 will still prevail in the industry. We have many implementations in the healthcare industry, which lakhs of implementations who have used HL7 V2 for their data exchange models. So HL7 V2 and Fire will coexist for a very long time, for next few years, at least 5 to 7 years, until there is a standardized mechanism to convert HL7 to move from HL7 V2 to Fire. And another point is people may move from V2 to fire, provided it's adding a value again. Let's say they have multiple interfaces to manage V2 and fire, then they may move everything to fire, right? So that's how it may happen, but not in the very near future. So it will take a lot of time. So we need to learn both HL7 V2, and if you want to upgrade yourself and be at mark in the industry, you can learn fire as well. So what are the advantages of having these data standards? It will be easy to share the medical data, demographic data, billing data, which is much more easier, faster to maintain the data in a very integrated format. And data transfer is always in the form of messages. There are no special tools that are required to go ahead and create the messages apart from using an integration engine. And then code is always human readable, which means people can go ahead and understand that just by reading the data. In case if you are not aware of the standard itself, if you keenly see the message, you'll be able to make out at least 3 or 4 terms from that particular messaging standard. It can work on any OS because it is OS independent. As we are operating at the application layer, construction of HL7 message happens at the application layer, so it is OS independent and can connect from any application to any application. Okay, and why do we need these standards? So one common answer, we have already seen that these standards will help us sharing of medical data and quicker insurance claims. But apart from that, apps can talk to each other quickly, meaning integrations can be established quickly. You don't need to bother about the data structure. You don't need to bother about the data format. And all that you have to do is you just need to implement the existing format out there. And this will ensure that there is greater safety for patient because patient's data is not manually intervened. So there is less scope of errors, which is why the quality will be maintained uh, at the highest with these standards. So any questions so far before we move on to the next topic? All right, I'm not hearing anything, so I hope that is clear. So let's proceed with the next set of slides. So far we have understood that we have a data format and we have HL7 messaging. How did the name come? And what are the advantages of following a standard? Now let us get a little bit deeper and understand how HL7 messaging works. Okay. HL7 messaging is primarily designed based on the fact that data that is getting exchanged will be exchanged whenever there is an event that happens. So what is that event? Let's say you have a patient getting registered. So patient providing his details and receptionist registering those details is an event. And if this event is demanding the data flow to be sent from one system to another, such event is called as a trigger event. Okay. So because it is triggering the data from one system to another. So that's the reason it is called as a trigger event. So there will be many such kind of events, but the basis of HL7 messaging are these trigger events. Okay, so there will be a sequence of events which we will see tomorrow. What are the few sequence of events that may happen? And we will try to understand what can be trigger event, what cannot, what is not a trigger event tomorrow. But to add a baseline, we can understand that an event that is happening in the real-time world, and if that event is demanding the data to be sent from one application to another, such event is called as a trigger event. So we'll talk more about this tomorrow, but HL7 works based on this model of trigger events. Now, let us look at uh, what at what points these trigger events can happen. So trigger events can occur during the registration process, or during the appointments, or during the labs, or during the medicine prescription exchange, or through invoices, right? So it can happen at any one of these workflow scenarios. We will see what all events we have individually for each one of these tomorrow. Now, now that we know from the hospital, the data might exchange or generated from registration. What kind of data? It is HL7. Appointment data, it's in the HL7 format. Labs in the HL7 format, and these are also in the HL7 format. Now let's look at the message structure. Now that we know data exchange happens as HL7 messages, let us look at the HL7 message structure and understand how to read it, how to understand the structure of the HL7 message. So a small metaphor here. Let's say we have a analogy where there are few different people at home, right? Or even before that, let me ask you. So let's say there is power outage and we are back in 1980s, or assume that we are back in 1980s or 1990s, and we have uh, a power outage. There are no mobiles, by the way. So what would be your first step? What would you do in your as your first step? Can someone tell me what you would have done back then?
We'll try to find a candle.
Right. You will try to find a candle. That's exactly right. So you will try to find a candle, but how do you navigate to that place? Because it will be totally dark, right? No one had this scenario. All right. So basically, what we'll do, we know where the candle is. So we place the candle at a certain place or at a certain location, and that is predefined. Everyone at home knows that. Similarly, let's say there is a rack at home and there are few different people at home. We define the structure of that rack, right? And say that, okay, first shelf is for clothes, second shelf is for books, and third shelf is also for, let's say, some other category of books. And within those shelves, first compartment is dedicated for t-shirts, second one is dedicated for trousers, and third one is for shirts. Now, when everyone at home uh, understands, or everyone at home feels that, everyone at home knows this structure, and let's say one of the person is going out and he forgot the t-shirt at home, he calls the other person at home and says, can you get me the t-shirt? The second person who is at home goes to the rack, opens it, and gets the t-shirt from the first shelf. The person who is outside doesn't say specifically where he has to get the t-shirt from, because the other person who is at home also knows that this is the structure they have to they I mean, this is the structure they have within the rack. HL7 works, or HL7 message standard, data standard, is very similar to this particular process. These two, based on, works same like the two analogies that we have seen. The data that we want to exchange between different applications is completely predefined with its placeholders. Meaning, where do we need to send patient name? Where do we need to send patient's date of birth? Where do we need to send patient's gender value, his language, his race and ethnicity values? All of these are predefined in a message structure. And all that you need to know is where exactly we can send what kind of data. Okay, that's the main principle or main thing with HL7 message structure. Everything is predefined. All that we have to do is know it and follow it. Okay, so in order to understand where we have what, first we need to understand the message structure. So let's see how the message is structured. So every HL7 message has a list of segments which can be compared to the shelves, and then each segment is divided into compartments which are called as fields. Okay, and these fields are further divided into components. Components are further divided into subcomponents. Okay, so this is the message structure. So let's look at an actual message to understand how to read an HL7 message. So even before moving to that, we also need to know what is the grammatical syntax in order to read the message, right? For example, if you have to read English, you should know what is space, what is full stop, what is comma, what is the paragraph beginning with, ending with, and so on. Similarly, HL7 message data standard has its own grammatical syntax. We call them as uses few punctuations. We call them as message delimiters or control characters. So let's look at those message delimiters or control characters. You can also call them as encoding characters. First one is a segment terminator, which is carriage return, meaning at the end of every segment there is a full stop. That full stop is nothing but carriage return. Next you have field separator. These are field separators can be called as spaces between two words. Two fields are separated from each other with the help of a pipe symbol. This symbol is called as pipe. Next is component separator. So this caret that you see, this is called as caret, and this is called as a component separator, which means within a field, if there are two components, they are separated with the help of this caret. Next, we have three more called as subcomponent separator, repetition separator, and escape character. We will see them with examples on the fly down the line whenever we come across these symbols. So this is how an HL7 message looks like. So if you are very new to HL7, then this would be the format. And as you can see, every HL7 message can be divided into different segments. Each segment begins with a three-letter acronym, and it will tell you what kind of data is present within that segment. If you go back to our slide where we were talking about the rack analogy, I said that first rack is for clothes, second rack is for books, third rack is for some other books, and so on, right? So similarly, whenever we talk about an HL7 message, it is divided into segment. Each segment has its own name. As you can see here, we have MSH, EVN, PID, NK1, and PV1. These segments will define what kind of data will be present in that particular segment. For example, if you take PID, PID stands for patient identification. So patient identification related data will be present in this particular segment. What kind of data? It may be patient name, patient's national number like SSN number in US, Aadhaar number in India, some other ID number in few other countries, right? And then patient's name, patient's date of birth, patient's gender, his address information, everything that is related to patient will be present in PID segment. Okay, so that's how HL7 message is divided. Now you may have other segments like PV1, which is patient visit data. So if this patient is visiting the hospital, what is his visit related information will be present in PV1 segment. Okay, MSH segment is the segment header, which is used to go ahead and um, tell who is sending the data, who is receiving the data, and so on. So let's look at PID segment little in detail to understand what is pipe and what is control characters. So this is not JavaScript, by the way. I have added it because I've set the language to JavaScript because it will beautify the things and we can clearly see what do we have. So as you can see, as you can see here, we have all the segments. And at the end of every segment, you can see we have CR. CR is mandatory. LF is not mandatory. LF is line feed, which will tell that go to next line. But at the end of every segment, you can see that we have CR. CR is the one which will tell that this is a full stop or this is the end of the segment. All right, let me remove that for now. And every segment has its own name, PV1, EVN, PID. So we are looking at PID specifically. So let's grab that. And within PID, you can see that every field, whatever is held between two pipes is called as a field. Every field is separated from each other with the help of pipe. Okay, so this is one field, this is one field, this is one field, this is one field, and so on. Okay, and every field will have its own field position. This is field number 1, this is field number 2, this is field number 3, this is field number 4, and this is field number 5, 6, 7, and so on. So there may be X number of fields depending on the type of the segment that you are dealing with. Few fields may be 10, few fields may be few segments may have 10 fields, few segments may have 15, few may have 20, etc. Okay. Okay. So, and these fields will have field positions. So now, if you talk about PID segment, PID 5 is dedicated or predefined to exchange patient name information. Okay. So this is position number 1, position number 2, position number 3, position number 4, and position number 5 in PID 5. So the way we read it is PID dot 5 is for patient name. Okay. Then PID dot 7 is for patient date of birth. Okay. In this way, there are other data elements as well that are predefined, and their location within the HL7 message structure and segment are predefined. Now, anyone who is in the world, now you guys also know, if you are given any HL7 message, let's say if I'm going to this HL7 message, okay, this is not a good example. This is stock update data. So, all right. But if you grab any HL7 message from anywhere, now you know I can go and find out the patient name because we know that PAD 5 has patient name, right? So that's how we figure out and we understand what kind of data is present where in the HL7 message. We'll explore more about caret, what are these empty fields, what is uh, what is the importance of sequencing and all in tomorrow's session. Okay, but this is how you go ahead and understand or look at the HL7 message structure and read it. Okay, so with that we'll conclude. We are uh, completing today's session. I'll talk few things about the training, but in tomorrow's session we are going to see a little bit more detail on the HL7 message structure, how to read segment, how to read the components, what is the thing with empty segments, empty fields, and so on. And we'll also talk about what are the various trigger events that we have. What is message type? What is trigger event? What is message code within a message type? And how to read the acronyms of message types and trigger events and so on. So we'll take a deeper look at HL7 message structure in detail. So that will be the pattern that we'll be following slowly. We'll look at the structure. We'll get deeper into that structure and understand the entire structure of every HL7 message type. Okay. So any questions from today's session so far?
Are we gonna get the recordings of each what do we call it, each session?
Yes. Yes. So basically, okay, let me talk about a few administrative aspects of the training. So uh, everyday session will be at this very same time. It will be for 1 hour, 45 minutes. We'll go through the session and 15 minutes we'll have a questionnaire in case if anyone has any questions or clarifications are required, we'll go through that. As soon as the session is done, it will take some time for processing the recording. Every session will be recorded and that will be uploaded to the Google Drive. So this we will share this Google Drive with you guys so that you guys can review and see the video again, or if you miss any session because of your time constraints, you can view the recording and then you can reach out to me if you have any questions, if you cannot reach out in the session itself. So in terms of reaching out, we'll be creating a WhatsApp group with all the participants who are enrolling in the training, and we will go ahead and we can communicate there in case if you guys have any questions after the session or if you are viewing the recording. Second thing is this training will be for 5 days in a week, starting Monday to Friday, Eastern time, Tuesday to Saturday Indian time, but morning 7 o'clock. 7 o'clock Indian time. Okay, and
So
yeah,
I'm
Michael,
sorry.
go
You
ahead.
Can you
said
say that again?
you said
How many days?
This will be around 28 sessions, so it will be for 5 to 6 weeks. Yeah, Michael, go ahead.
no. I think he asked the question. Like I just wanted to know how long it was gonna
Right,
last for.
right.
But you said 5 to 6. So okay. And after the whole thingy, right? What is the next? Like like can we? Do you help with like maybe resumes and stuff like that, or is just after you're done? Is there training that you have to take? Is there a test or something? Oh no.
No, I mean, you can, I mean, after the training is done, you can still ask me the questions. I'm in touch with many people for over the past few years who have taken training from me in the last 6 years as well. So we will still be in touch. You can ask me questions and I will be able to answer that. And help with resumes. If you want me to review your resume, I can review it and I will provide my inputs in order to update that a little better.
So one quick question: do we also cover fire in this session, or there is a separate session for that?
No, Gaurav, this is HL7 only. Fire, we have next session from 8 to 9 India time.
So there is a separate, training classes for
Correct,
those.
correct. Separate training for fire. Fire is totally different, right? So different standard. So we have separate course for fire.
And about the interfaces, do you have any, classes for the interfaces? Like, if I want to know, like, how do we, handle interfaces? What are the different operations within the interfaces or the functionality?
Right. So, yeah. So let me tell about the content. So, in this training, the first part will be purely about HL7. Part 1 will be about HL7 data structure. So we'll take a deeper look at how do you read various message structures, and we will see uh, ADT, SIU, DFT, ORM, ORU, all of these HL7 message structures in detail. Once we know that this is how the structure looks like, second part would be understanding Mirth integration engine. So with Mirth integration engine, we will go ahead and take a look at the technical part of how do we build these messages. Let's say you are given a database and you want to construct an HL7 messages for patient registration, or you want to send out an order and you want to construct an HL7 message for that order. So we will see how to use Mirth integration engine to build these interfaces from scratch. Okay. And we will see in detail about various connection models. How do you use TCP/IP? How do you use database connection? How do you use file reader to file writer? What are the challenges that we will get while building these interfaces? We'll also see how do we interpret HL7 messages and write the data back to the database. All of these will be covered as part of Mirth integration training. I will have Shrinivas share with you, all of you, the HL7 course curriculum, which will talk in detail about what are the things that are covered as part of this training.
Actually, like, I have a question in this one. Can I ask here?
Yes, yes, go ahead.
So, I mean, my question is specifically to the interface. When we talk about the interface, like, there are certain logics that we can write within this, like
Mm-hmm.
when getting the HL7 message from application 1 and we need to send it to application 2. So, there are certain logics that we can write within the interface. So, are
Right.
we talking about when we discuss Mirth integration?
Mm-hmm.
So, it's only the creation of the HL7 messages, or discussing the logic through which we can, route these messages to specific applications. Do we also cover that in this course, or there is a separate session altogether for that?
We will cover the basic stuff of how do we use routing logics, how do we use validate the HL7 messages. We will see code snippets, let's say, for example, you will have, see, basically from interface perspective, you will have many different business logics, right? Out of
Right.
them, we will be looking at the common logics like how do you validate if some data is missing? How do you validate certain value from the data and route the message accordingly? How do you use filters in order to route the data in that format? So we'll be seeing those aspects.
Okay, sure.
But we may not cover everything out there in the business aspect. The whole idea is for you to understand how do you implement certain business logics, and how do you format or formulate that logic within your business use case may be different. But I'll be covering basic aspects of what are the common logics that we'll be using for sure.
So if I want to
Okay.
dig down into into the interface aspect, do you run any separate session apart from HL7 or the Fire? Do you have any other session or
No,
like,
no, 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 because it is very business use case specific, and we will have to uh, build based on those logics that we get for a certain business use case. Common aspects of logics, anyways, I'm going to cover that.
sure? Thank you.
Can I,
Yep, no
can I
problem.
ask a question? One last question for me.
Yeah,
Are you
Michael,
gonna be
go ahead.
giving us? Are you gonna be giving us like maybe homework, or no? It's just basically we
Yes,
just
we will have
okay,
assignments for
okay,
HL7. We'll have assignments for Mirth integration engine, uh, so that you can build whatever we are learning in the training.
okay, okay.
Okay, any other questions from anyone? All right. So if you guys can drop your, so Srinivas is the coordinator, so you can go ahead and reach out to him for any questions that you may have, and he will share the course curriculum with all of you guys. I request you guys to drop your email address, phone number, and your name to Srinivas if you would like to enroll in the training. Tomorrow's session is also a free session. You guys can go ahead and join. And from third session, people who are enrolling uh, can go ahead and join the sessions further. Okay. So thank you, everybody. You all have a good day. We'll catch up
Thank
tomorrow.
you.